So we'll talk a bit about OOP, or as we like to call it in our business, OOPS, because it just sounds more fun, right? Object-oriented programming, software, system. It just looks better with an S after it. But the real term is OOP. We'll do a brief intro. We've done a bit of this in the first week or two. Anybody remember vampires? Yeah, it was fun. Yeah, vampires and the org chart, that kind of stuff. We'll do a very small bit of it. No recursion, none of that stuff. We'll just do a really quick review of OOP and classes, which we used before. We'll make ourselves a Create React app. Will we? Well, we might not use Create React app. I think we'll use something else. And then we'll talk about how we'd go about writing a class-based component. As you can imagine, they're based on classes, of course. And then we dive into the actual details of how we do React apps with our props, handling events like on click, callbacks, in other words, and of course, state, a bit of an exclamation mark beside that one, kind of fun. Then we'll talk about how class components did things we normally do with functional components. There's these things called life cycle methods. Maybe it should be a dash in there. How's that? No, I don't think so. Okay. And there's a few of them, and we had to use those. And we'll talk a bit about the history, where the stuff came from, and where React is now, where we started. And then we'll talk about at the very end when we should actually use class components in our code. Okay, and we'll talk about really when we should use them. All right. So let's talk about object-oriented programming, or OOP. Okay. Remember back we worked in, it was vampires, and we did mostly for recursion, and the actual class was really an afterthought. We didn't do a lot of using classes in a real way. We just used it so we could demonstrate this concept of recursion. So we won't be doing any recursion today, but we're going to do a little more with classes. Now, one thing about classes we have to be really clear on in JavaScript, classes don't really exist. They're not there. They're an illusion. It's one of those things called syntactic sugar. They just made up some words to do things, but they don't really exist. In ES6, they just added this class word, but it didn't add anything new to the language. They just gave a name to something that already existed. In other words, they're just functions. Classes are actually functions, but they added this new sugar. They wrapped them in a nice sugary coating to make your life easy to create things that appeared to be classes. And it's fine. You can treat them for the most part like classes. Okay. JavaScript has lots of these syntactic sugars. You may have seen in your travels async await as well, and thinking, hey, this is a great way I can get out of using promises. No, those equal, I'll say two equal sign promises. They just are. They're just another sugar coating around promises. So just we know that classes, JavaScript doesn't have real classes, and they have some limitations and some strangeness around them. It won't affect what we're doing today, but just keep it in mind for later that classes don't exist, and you can't treat them like real classes like in other languages that have true classes, languages like C++ or Java or Kotlin or C#, or in Ruby, which we'll be working with in a couple of weeks here. Okay. So let's make ourselves a little file. Go ahead, make a file here. I'll call it class demo.js. There. Another one of my unimaginative names. So I'll make myself a class. Now we know that we can make a class by simply using the class word, right? We simply say class and my class there, and we have curly braces, no semicolon, turns out. Auto formatter doesn't add semicolon. That's a class definition. So now I have class. This is, as we know, it's a template from which we can build objects. We made a bunch of vampire classes. We build vampires. So this is a class, and I can make an object based on that class. So const obj equals, and of course we use the word to instantiate a class. We use new, which is pretty common in a lot of languages. C, C++ rather, and Java, and the other C family of languages, of which JavaScript is one. All use the word new, and I'd go new my class. Classes generally have an uppercase name, and objects would have a lowercase. That's just a convention you'll see really through all the C family of languages. There's my class, and there's my object from that class, and I can console log that thing. Console log my obj. Let's take a look. There's my class demo. So node class demo.js. There. Well, that's what I expected. Interesting, when you console log an object based on a class, you get the name of the class first, and then the curly braces. But apart from that, it looks like any other objects. We know that we can have content in our classes. So if I make a class, for instance, let's make another one, class. I'm going to make a rectangle. There. And a rectangle probably has a length and a width. When we instantiate a class, remember we talked about instantiating functions where the function is a template, and then we run the function many times. Each time you run that function, you get an instance of that function. Okay, well, a class is like really a persistent instance of a function that is based on a class. Okay, so we can make a constructor. Constructor. There. So when we instantiate a class with this word new, we run it kind of like a function. New my class, and we call the class with parentheses like a function, and that instantiates that class. And what happens is this constructor gets run when we instantiate the class. We talked about this earlier, of course, in week 1. Okay, and we can pass parameters as well. So I can go const, I'll just say rec equals new rectangle. There. And if I gave a parameter to this, like I'll go maybe length and width. So I'll say maybe 3 and 4. Okay, so my constructor can take two parameters, length and width. Okay, and I can console log those things. Let's just console log the length and width. And I run it again. Exactly what expected, just like a function. So we have our rectangle class, which is, for all intents, is a class, runs a constructor. So we can, of course, create or assign members to the class. Okay, so I would go this dot length equals length. And what this does, it'll create an item called length inside the object, and the same with width. And let's console log our length. We'll console log our rec. So you noticed we console log the instantiation of the rectangle. We watch the constructor run. So now we'll console log our actual object. And there we get, no surprise, a rectangle with length and width. So far, this is stuff we already know. We also know that we can have methods, well, it's just functions. The terminology gets a bit different. We talk about this thing called OOP, and Functions inside a class are usually called methods. Why'd they call it methods? I don't know. They called it. So we can make a method called area as a function. We won't talk about this weird thing called get. We're not doing that today. Okay, we'll just go with the classic classes. Okay, so and an area can simply return the length times the width. Some pretty heavy math here. Okay, and of course now I can call this this method. I can say console log my rec dot area, and area is a function, unless I put the word get. Okay, I'm still kind of torn as to whether or not I like that get thing or not. Coming from a C Java background, to me it's kind of weird, but some people like it. And I think it has some good use cases. Okay, but to me it just confuses me. Okay, so there's my area, and I should get length is not defined. Ah, what happened? What's going on? Well, this it all works. Well, of course, we know in JavaScript classes, unlike other languages, when you refer to a member of that class, okay, you have to use, of course, you have to use this. That's one of the gotchas about JavaScript classes, okay? You have to say this dot length. And you have to say this dot width, and this is going to come back to haunt us. And that's actually a joke, which we'll get later, that sentence. This is going to come back to haunt us. So it's actually pretty funny. Take it again, and now it runs. And my array is 12. So far, so good. Okay. So now I can extend this class. We didn't do a lot of this before. We can have what's called extension. You can extend classes. I can make another class based on this class. So let's say I want to make something, what could be based on a rectangle? Let's make something that's three-dimensional. A rectangle is two-dimensional. I'm going to make a three-dimensional object. Okay, class. And I did look around, and I discovered that the mathematical term for a three-dimensional rectangle, anyone know what that is? What's the mathematical term for a three-dimensional rectangle? In other words, a rectangle with height. I didn't know this one. I was a math major or engineer major, so it's called a rectangular prism. That's a mouthful. I'm just going to call it prism, or maybe Priz for short. Okay, I'll call it prism. Not exactly precise, but I'm not typing rectangular prism all day. Okay, so we'll call it a prism, and we use the word extends. It extends a rectangle. There. And there we go. And we can do now, we can actually run this. Let's try this. Let's make a new prism. So we'll take that one. Let's make a const. We'll call it priz equals a new prism with no parameters for now. Let's watch what happens. Oh, undefined, undefined. Makes sense. Okay. Let's just move our constructor out of here. Watch what happens. Okay. So there's my rectangle. And there, take this out, make it more clear. And we'll console log our, where'd my priz go? Console log my priz. There we go. Okay, well, it makes sense. I have a prism, but it still has length and width, but I didn't give anything. So it has undefined. So it still gets everything the rectangle had, it's undefined. And I can give the same parameters. I can go 3, 4. And what's going to happen here? Let's take a look. In fact, let's go 4, 5. 4 and 5. What do we get here? We get a prism with a length of 4 width of 5. That's interesting. So it looks like it really behaves exactly like a rectangle. That's this concept. You hear all these concepts in OOP. This is a concept of ISA. I know it's weird. What? What do you say? Is a prism is a rectangle. So it's actually, this is the thing, ISA. So it is a rectangle. There's these concepts in software, ISA versus HASA. I know these guys gotta get out more, really. ISA means it is this thing. Has means it has inside it these things. So it's the whole ISA versus HASA debate, which is a huge debate in my business. So I know, yeah, we're all nerds. Okay, all right. So a prism is a rectangle. Cool. Okay, so that's all it is right now because it's nothing else. Has no personality of its own. It's just a blank rectangle. So we can give it more personality. Okay, we can maybe have a constructor there. That maybe takes what? Well, does it take just a height? Well, it can't, because then when we create a rectangle, the length, which is undefined, it has to have more things. It needs the length and the width and a height. That defines a prism. Now, they can be in any order. It doesn't have to have the same order. It's not important. I'll make them the same just for consistency, but they don't have to be in any particular order. Okay, there. And I can go this dot height equals height. And what's going to happen here? Run this again. Let's put a clear and a semicolon in front of that. That'll clear our screen each time. There we go. Oh, I get some nasty error. So what does it say? It says you must call the superconstructor in the derived class before accessing this. It says on my line 19. So this is one of those rules. Another joke, another this joke. Okay, I gotta. The jokes write themselves in this lecture. I'll tell you, not write themselves very well is all. So it says it can't access this until you call what's called the superconstructor. What the heck's a superconstructor? I know what a constructor is. What's a superconstructor? Well, this is more jargon. Okay, so time for some jargon. We have this class called prism. It extends rectangle. That means that it is a class derived from the rectangle. Sometimes you'll see the word called a subclass. It is a subclass, like a subspecies of a rectangle. So this is the subclass. This, of course, becomes the superclass. Yes. Da, da, da. Okay. Yes, it's a superclass. So this is the constructor. Well, guess what this is? The superconstructor. I love these words. It's called the superconstructor. So, and the rule is if you have a constructor in your subclass, you have to, unless you want the default constructor, if we just this, it will simply call by default our constructor. So if I just do this, we saw before it called this constructor anyway. But if we're accessing this ourselves, we have to explicitly call the superconstructor. I know it gets kind of weird. It's one of those rules. So we have to call the superconstructor. And the way we do that is by, who wants to guess what the word is? Anyone? Super, yes, or supre. I like supre better. Supre, but unfortunately JavaScript doesn't like that. So super, yeah, we say super. This, by the way, is not unique to JavaScript. This is the same in Java and all the other OOP languages that are based on C, which is most of them, okay, including JavaScript. Super. We can go super by itself, but the constructor, this doesn't have a no parameter constructor. It has two parameters that have to go length and width. And width. And now I understand this could be in a separate order, right? We simply do this. It doesn't matter this order because we have to, as long as we call the super in the correct order, everything works, but we'll keep them consistent. So now we call super length width, and then we can access this, and then we can get stuff working. Okay. All right. Of course, now we have to give it a height. So give it 4, 5, and 6. And now I get 4, 5, 6. And there is my new prism. By the way, we're almost finished everything we need to know about classes for this lecture, okay? There's a lot more cool things going on, but it's just not really a huge deal, okay? Now, interestingly enough, of course, because this is a derived class, a subclass, we talked about the concept of extension. You can extend classes. So there are some pillars of OOP and all this other jargon. We won't talk about them all. One of the ones we need to worry about is this thing called inheritance, where we inherit the features of the class. So since a prism is a rectangle, it means it also has all the things a rectangle has. It has a length, a width, and it has an area. Well, I can go pris dot length, and I'd get my length. I can also constant pris dot area, and I can call the area like that. So I inherit these methods, okay? And of course, I can add more. We can make one, which is a volume. And we'll just return. We can go this. We learned that lesson last time. This dot length times this dot width times this dot height. And now I can call my volume. So don't get confused. I'm going to go volume equals not a number. What happened? Let's take a look. So let's calculate what happened here. Think. Typo in my, you're right. There we go. 120. Nice round number. Okay. This is almost everything we have to know about classes, really. One thing we can do, since we know this, we can, of course, call our superclass methods, okay? We can go area. There, we could call the area function, that is length times the dot width. We call that, and of course, we get an error because we forgot the word this again. Yes. This is a problem with classes. Okay. Okay. All right. This is kind of it. Another this joke. All will become clear later. Okay. I know. All right. So that's all we have to know. Classes. There's inheritance, and when you extend a class, you just get for free all the other stuff. Okay. If you want to have your own stuff, you have to call the constructor, and that's kind of it. So this concept of inheritance, and we won't talk with other things like polymorphism. Anyone heard that term? We're not going there. Other things as well. OOP is a really cool concept in software development. It doesn't lend itself that well to JavaScript, unfortunately, but to other languages like Java, it is really cool where you can actually access, because what if I had a method called area here, right? Well, now I've got two of them. What's going to happen here? Well, it turns out you've got this concept of this area, and this is the super area. Hey, okay, lots of cool things. We will not go in any of those directions right now. So this is all we need to know about classes. So let's go ahead and do something with React, because this is kind of enough playing with this stuff. Okay. So I've gone ahead and built myself a nice small React app. I think I have it running someplace. Let me take a look. I had it in this window. Yeah, there it is. And I used Vite. Yes. Anyone try Vite yet to make an app? It's pretty cool, right? So we know we can press H for help, and we can do our stuff. And I think this one's pretty brand new. Let's press O for open. in my browser. There it is. Hello React class. And I've got my app.js right there. Okay. So let's go ahead and build ourselves a pretty simple React class. Okay. So how do we build ourselves a class in React? Pretty straightforward. What we have to do is we simply make a new file. I'll call it, put it right here. I'll call it my class component. So my, capital C, class component dot JSX, because Vita insists on having JSX. Okay. And make a class. Go class, and we'll call it my class component. There. Now we could do it like this, and this is just a JavaScript class. So to make a React class, we have to extend one of the built-in React classes. Okay. So extends once again, and we extend component. Take a look here, and sure enough, there is component right here in React. And yeah, you can import component from React. And now I have a React class component, almost. Okay, now remember in functional components, the definition of a functional component is a function that returns JSX. We know that now. Well, a class component has to render something. Okay, in fact, let's try this all by itself. Let's go ahead and export this thing. Export default. My class component. There. And we'll use our class component. Now, class components, when you use them, we use them exactly the same way as any component. In fact, when using them, we don't even know that they are class components. That's the beauty. We can use class components and not know where they came from. In fact, a lot of the libraries that you'll be using, or you'll see, they're probably using class components under the covers, but we don't know that. They're just components. So now I can use my class component. I'll say my class component. Like that. There. Okay. And, well, nothing rendered. So what is it saying here? It says render is not a function. Render is not a function. No render. No render. Render. Well, I have a feeling it's trying to tell me something. I haven't got a render. Okay. And that's the second thing a class component needs. It needs a render. Now we know any functional component, a render is just run the function, but this is not a function. This is now a class. We'll talk about how they behave, and it's different. It needs to be, it's been instantiated, but now it's looking for a render. So React has instantiated this class component in our app, and it tried to render it, and it says, I can't render this thing because you need to define render. And that's what we need, render, okay? So we need a render function there, okay? What do we get now? Okay, let's take a look. Is it getting happier? Where's my logs? There we go. Okay, so it's happy. I'm rendering something. Now, interestingly, it's not an error to render nothing. It just calls a render function. Unlike with a functional component, you have to return JSX. A render is perfectly happy to return nothing. I'm going to put my dev tools at the bottom again. They actually work better in a React at the bottom. I was teaching a CSS class, so on a CSS, they're better on the side. But when you top doing JavaScript, it is by far better to have your dev tools at the bottom. It's much more to see. Okay. Okay, so I have to return something. Return. And this becomes exactly the same as a functional component. We can return JSX. So I'll make a div, and I'll say class, my class component, my class component. Just like a functional component would look like, and there it is. Okay, so this part's about the same. So this is not bad. We can kind of deal with this. We got some stuff happening here. We got stuff here, kind of like a functional component. Just have this weird render thing that's going on here. Okay, we'll talk more about the life cycle of a component a little later. But what's happening is the class is being instantiated by React, and then it runs the render. And this is what runs on every render, just this part. And that's the major difference between a class component and a function component is only this part runs every render. Unlike a functional component, which runs the whole thing, now it's only part. Now you may think that has some advantages, and you'd be completely correct. There are some advantages to using a class component, but we'll talk about why those don't matter a little later. Okay. But this is why when they first wrote React, they built up on classes where they could instantiate and simply run this this part. Okay, so this is your basic class component. Okay. So how would I go about using my my class component? So I want to be able to pass some props to my class component. So in my app.js, what I'll do is I'll give it some props. I'll give it text. Text equals, and I'll just say hello. So we use the component just like we'd use a regular component. We don't really know whether it's a class component or a function component, and it really doesn't matter at this level. Now, inside my class component, now I want to be able to use those props. Now, of course, this is not a function, so I don't get some parameters like this passed because that doesn't make any sense. That's not how a class is defined, so we can't do that. So how do I pass props to my class component? Perhaps it ends up as a parameter on the render. Well, that's actually not what happens either. What we get is we get an inherited props. This is a class. It extends the component class from React. And we inherit a bunch of things from that. One of those things we inherit is props. So we inherit this dot props. And we can use that. So what I can do is I can put my this dot props dot text right here. And I should see my hello. So now I can pass props to my class component. Commonly what you'll see is instead of using this dot props, oftentimes we'll make a variable const and we call it props equals this dot props, just to make our code a little more friendly, or something we're used to seeing. We just see props, okay? Or you might even see destructuring. You might see this where you have text equals this dot props destructured, and then you would just render text. Really, it's a matter of choice. I tend to like going with this. Just have my props there and refer to my props this way. All right, so now I can pass some props. Now our class component also has a constructor. We can give it a constructor, say constructor. Right. And the constructor gets as a parameter, you probably guessed it, props. Now you may notice that my app doesn't look too happy. Let's take a look and see what my DevTools is saying. It says, oh, must call superconstructor before calling this in a derived class. Huh. So it looks like the same rules apply that applied in our other class. Before we access this, because we're accessing this in our render, we need to call the superconstructor. And this is really exactly the same way we called it in our rectangle class and our prism class. We call Super. And the constructor also takes props. So we have to add this line. And now our app is happy again. So there's the complete pattern for a class component that takes in props. We have our class component extends the component. We have a constructor that takes props called super props. This is really just boilerplate. We have our render, and sometimes we like to make a props variable. So we have basically the working skeleton now of a functional class component. Let's talk a little bit about state, and we'll talk about callback functions, because this is where it gets a little unusual in class components, okay? So for instance, let's make myself some state. So how do we define state in class components? Kind of like this. And this is going to make a lot of sense in a few minutes. We define things called this dot state equals an object. Now this probably looks really familiar. Having a object or a called state. So you get one object in class components. You can only have one state. And that's the interesting thing about class components. You only get one shot. There's your state. You can't have anything else. It has to be called state spelled that way. And you can put stuff inside your state. You can put counter :0. There we go. Okay. Okay, well, how do I go ahead and render my state? Well, let's put our state here. Put it inside there. Now we can't just go counter, can we? How about state.counter? Well, you probably guessed you can't do that. Okay. What it expects to see instead, it wants to see the this instead. Okay, there. Let's give ourselves a single parent so it doesn't complain. There we go. Okay. This dot state dot counter. Okay, I got a 0. This is a real problem with class components. There's my counter. So far, it's not that bad. You kind of have to declare this state object here. You have to refer to your props with this, and you have to go this dot state dot counter. You can't just have counter. But so far, it's not so bad. I can probably live with this. This is where it becomes a little bit of an issue. I want to make a button to change that that state, okay? And this is, pun intended, this is where it gets a little strange. Let's go ahead and make ourselves a button. So it'll be in the render, makes sense. I'll put a button here. Oops. There we go. Put a plus sign. At least that kind of works as expected. Okay. And now I want to make this button do something. In other words, I want an event handler for this button. Well, just like we do in functional components, we'd have an on click. On click equals some function. And I'll call it, well, increment. There. So you'd think I probably need a function called increment in my my class. And I do. Let's go ahead and make one of those. So I'm going to put it, there's my constructor. So functions, of course, go here. So increment, there's my function, and there. And let's console log. Increment, just so we can satisfy ourselves, we in fact call this function. Okay. Got an error again. Anchor is not defined. On line 24. What did I forget? I forgot this, right? Have to go this. Okay. Happy now? Seems to be. Okay, what else can go wrong? Click plus. Well, that worked. Okay, we're getting somewhere now. I'm finally calling my increment function. Okay. Well, now it looks like I'm all set, right? All I need to now is to change this state. Well, how do we do that? How do we set some state? Well, let's go ahead and set some state. So the only way we can set state, we only have one state. It's called state. If this were a functional component, we'd have state called counter. We'd have counter set counter. We'd have text set text. We just have state. So what do you think the name of the function is to change state? Yes, it's set state. Set state. There. And of course, it wants this, if I was trying to be helpful. Okay, I guess I can't have any errors here. This dot set state. Let's just set state to, well, it has to be an object. So it has to be an object with a new counter in it. We'll just set state to 1 for now, just for fun, okay? Oh, okay, let's give it a try. And what's it saying now? This is undefined. Again? Okay, so this is actually one of the biggest problems with React class components. By the way, there's no logical error in my code, right? I should be able to call set state. Set state is a function, but why am I getting this is undefined? It doesn't make any sense, okay? Let's try something else. Why don't we instead, let's console log maybe this is console log the counter. This dot state dot counter. We'll just console log that. Okay, what can go wrong with that? What? This is undefined. Once again, it is a bit of a joke. This is a real problem in class components. Not only do you have to use this all the time, sometimes it's not even there. How can this, in fact, let's console log this. Let's console log this. This is always got to be there, right? We're inside an object. This has to be there. Let's take a look. Undefined. This is undefined. Okay. So on line 13, yeah, that's exactly right. This, the actual this of this object is undefined. But how can that happen? Objects have to have a this. That is like, it's not possible. Inconceivable. I love that show. Inconceivable. How can this not even be there? It's not possible. It was here, worked fine. But all of a sudden, this for some reason became undefined. And this is the problem with class components, okay? Why don't we take a short break? We'll come back and we'll solve this mystery because this really is a problem. Oh, I love this joke. Okay, keeps on giving. Let's go ahead and take a quick attendance. Let's in the chat, let's just say this is a problem, okay, with class components, because it really is. This will be our attendance. So we should get 9 of those. This is a problem. Yes, it is a problem because this code is correct. But we'll talk about in a few minutes why this is such a problem with class components. It actually makes sense that this really is undefined. We'll talk about that right after the break. Okay, so we have learned that this really is a problem with class components because we're getting this being undefined, which seems inconceivable. My new favorite word. Okay. Why is this happening? What's going on? Why is this undefined? And it actually is. And turns out it's actually following the rules. This actually makes sense that this really should be undefined at this point in time. It's really interesting to find out. So let's take a look what's happening here. We have our event handler, increment. It is being called in response to an on click. Remember, we're in class land now, where everything has this, and there's always a context of who is doing what. Remember in jQuery, and we had our event handlers, and we'd go, something would have an on-click listener. We'd click, and we'd get a concept of this. Well, what was it that was the this in our jQuery handler? It was the thing that generated the event, or the thing we put the listener on. Remember, we put a on click on a button, for instance. The button jQuery object would be the this. So it is the button that is the this. Well, that's what's happening here. We put an on click on this button. So guess what the this is? This is, we're calling event handler from the DOM. And you would think that, well, this would normally just be the window, right? The context of this browser. But what happens is, and there's some funny rules, the default binding of this generally is what's called the global object. So any binding inside your DOM is the global object, okay? And that is the window. But the window is undefined if running in strict mode. We have these two JavaScript rules that kind of conflict with each other. We have the rule that any function with what's called default binding of this, in other words, just default, it inherits the window as this. But this isn't window. This is undefined. But the rule says, unless you're running in strict mode, there's that. And then JavaScript goes on to say, but any body inside a class is by definition in strict mode. So what it means is rule number one, in the DOM, default binding means the window, unless you're in strict mode, in which case it's undefined. And the second rule is when you're inside a class, you're in strict mode. So what it means is this here should have been the window object, but it's undefined because we're in a class. That make any sense? It doesn't make sense to me either. No. Basically means this is a problem. That's what it really means. But there is, my point is, there is a certain degree of logic to why this happens. Okay, it follows the rules of DOM and JavaScript. But because of these two obscure rules that no one knows about, this ends up being undefined. But that's not my problem. My problem is this is undefined. I don't care why. I've got a this. I can't do anything. So what can I do? This is my problem. Okay. How can I fix this? This is how we fix it. Right now, I've got a this that is the wrong this. In other words, the this of this increment function, right? This increment function has got the wrong this. Okay. What I want an increment function that has the right this. Which this do I want? I want this thing. I want this. See, told you this was a big joke in class components. This really is a problem. So once again, my increment function has got the wrong this when it's called. Yeah, this is killing me. Exactly. Yes, thank you. I want this function to not have whatever this thing is. I want to have this. This works. Like here, this makes sense, right? This is fine, but for some reason, this increment function got a different this. I want an increment function that has the correct this, and this is how we fix it. You're going to love this. We have to change the increment function. Increment equals, oh, I have to go this dot. I need a new increment function. I'm going to make myself a new function called increment. Okay. And take the old one, this dot increment, increment with an N. Okay. And I'm going to change its this binding. You can do that. How to do that? How to change this? It's actually a thing. How to change the this of a function. There we go. There. Apparently you can. Okay. Using bind, you can change the this of a function using the bind function. That's what we want. We want this increment to have a different this. Okay, so dot bind. Well, bind to what? What this do we want to have this increment to have as its this? Anybody? There's only one word it could be. It is this. This. How are we liking class components so far? Yeah, they're fun. I love them. Okay. Yeah. What the heck is that? This increment, which means make a new function or a new member with the name increment, make it equal to the old one binding to the this that exists right now. Wow. Is it going to be the same in Ruby? No, it is not the same Ruby. Okay. This is one of those gymnastics or contortions we had to do with class components because this is a problem. Let's take a look now. I'm afraid to press the this or the plus button. Oh, I got something. Look at this. This is now an object. What's it look like? Hey, this looks like my object. It is. This is my component object. So it looks like now my increment function has a this with the correct this. Okay, so now I should be able to this dot state dot counter. 0, 0, there we go, 0, 0, 0. Looking good. Now I can call the set state function. So we'll call this dot set state to a new object, have to do that, with the counter equal to counter plus 1. Oh, no, this dot counter plus 1. Okay. Not bad. I'm getting closer at least. Okay. Okay. This dot state dot counter. And look at that. I have a working counter. That was a lot of work to go through for it to get a counter working, wasn't it? Class components are a little peculiar this way in the way they handle this and callbacks there. But now it works. So not so bad. I just have to do this for every single named function or named callback. That's all. And we got used to it. As React developers, we just did it. We made a function, make one logical decrement. I just copied the code. Like in fact, we had all kinds of snippet keys that would just do this. Like literally do it all for you, like in a single keystroke. Come on, there we go. Whoops, maybe rename it decrement. Decrement, there. There we go. Make a minus button now, and I should have a decrement button. There. Close. And now it's -1. There, plus, minus. Okay, so now we're getting somewhere. It's not that as bad as it sounds, but understanding why it happened. It's because this goes weird inside callbacks because now the callback is happening inside the DOM. That's all. We had to handle it using this weird gymnastics of binding with this. Okay. Kind of interesting stuff, right? But once you get used to it, it's not so bad. Let's do something else here. Let's watch what happens to our state. There's one other interesting thing about state. Why don't we make ourselves some text, okay? I'm gonna make a little, maybe an input or something. Go ahead, grab one here. There. Let's make an input. I'll put it under here. There. Make a div. There. Well, that was a button. What about inputs? You can hardly wait. I can tell what we have to do to make an input work. So input. There. And okay, well, that worked. No, this is undefined. Okay, so with an input, it's the same thing. Nothing changes. We have to connect our input with a value and an on change. That much didn't change. So let's make some state. We only have one, so I guess I got to put it here. We only get one, so I'll call this my text, and we'll make it an empty string. There. Okay. So my input has to have a value equal to, has to be this dot state dot text. What it's saying is I have an uncontrolled input. It's actually the class components, they're much more mature in their error messages. So this is telling me I'm missing an on change. So this is actually what I expect, right? I'll give it an on change. On change equals, okay. So let's just do it inline this time, okay? Let's do it like this. We go for the event, and then we'll call our this dot set state, and we'll call it with the new object. I'm doing it inline here. Okay, make a new object with our text equal to the e dot target dot values. Make it a little smaller. There. So all I've done is, instead of making a named function, I'm just doing this instead. Okay. How am I doing here? Well, no errors so far. Okay, and it looks like it's working. Okay. So I just took this. I could have made this a function, but I put it as an anonymous function instead. Right. So event and set state to an object that contains text with e.target.value. Okay. What should happen now? What do we think is going to happen? What if I start typing? Well, if I type a character here, it's going to call what? It's going to call my on change, which means it's going to call set state with this object, text with probably an A in it. What have I done here? I've said set state to the object. But remember, there's only one state object. It contains everything, including my counter. But I'm only setting state to that. And I'm only setting state here to that. What do we expect to happen now? I'm setting state to a new object that only contains text, although I know that my state contains counter and text. Let's watch. Huh. That was unexpected. I expect it was going to blow away my counter, right? Because if I'm replacing my state object that had counter and text only with an object that contained text only, I should have lost my counter. And the same with my counter. If I press that, it's replacing my state with an object that only contains counter, not text. But for some reason, it's working. That's kind of cool. So, turns out when you set state in a class component, it does a merge of the object. Means you don't have to worry about it. Which means no more spread out. You don't have to go dot, 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 state, comma. No, it takes care of that for you. Now that's actually not bad. Finally, something that's easier with class components is you can set state. It doesn't destroy anything else in the object because you only have one state object. So you can just go set state with your thing right there. It'll go, yeah, I got this one. And React only replaces what it needs to. It doesn't replace the whole object. So finally, something that's a little better with class components. Okay. One thing else you might have noticed. Why did this even work? This is a callback. We had so much trouble with our button and this bind thing. Well, why is this working suddenly? We didn't do a this dot bind dot this to this thing on this thing. Why is it working? Well, it's because it's an arrow function, right? And we know that arrow functions don't have a this. They just don't have a concept, so it inherits the this of this object here, right? So this here does not bind to the DOM. It simply gets the this from the overall object, which is, of course, our good this. Crystal clear, right? Yes. Okay. I love class components. So what you can do, if you have simple code, you can do it inline like this. So what ended up happening was, guess what people did? Everyone started writing code like this, and they did a whole bunch of stuff, and they just did more and more complex things. We ended up with like 30, 40, 50 line functions buried inside our template like this, and did all kinds of stuff. Lots of code like this. And you will see that to this day. People that do maps and a whole bunch of code inside the callback. And they shouldn't be doing that, okay? With functional components, we just make a callback. If it's more than a single line, we make a function. There, it's simple, right? But because with class components, we had this weird thing with this, people just got annoyed and they just simply stuck everything in line with an arrow function. We don't do that in class components. And if you see code that has a whole bunch of code buried, in fact, it should be like this. Let's take like this, there. Oops, come on. There we go. This there, and this one there, and there, there. I have to return. Okay. Okay. There we go. Still works. So you would oftentimes see a lot of code in here. Console logs, maybe, on change, but calculations, all kinds of stuff. We strongly discourage this now in functional components. People did it all the time because they had to, because of this weirdness with this. They stuck a lot of stuff, and you will see a lot of code of old timers, I call them, that are so used to using state objects and a lot of code in their template, it just bleeds into modern React. So if you see code with a lot of code inside the template like this, you probably know the person that wrote it probably is just so used to writing class components that they just lost track of the new world, okay? Now for one-liner, totally fine. Nothing wrong with that. Oops, how am I doing? There we go. There, okay. So for a single one-liner, no problem. But for complex stuff, make yourself a named function, okay? And bite the bullet with this thing, right? So that's how we use state and callbacks. Turns out state's not that bad. It does the merge thing for us, so this is okay. Okay, we don't have to worry about dot dot dot. We don't have to go dot 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 state. Of course, it's going to be dot 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 this dot state, right? Comma, not needed, because turns out React is the merge for us. Kind of a small benefit of using React class components. Okay. So there's our usual, oh, and I've got comma right there. There we go. Cool. All right. So we have our basics. We have our props, we have our state, we have our callbacks, kind of the usual things we deal with. Now let's talk about, well, how do we get our React app to do stuff at certain times? Now, did you cover use effect in the lecture? Was it Friday or Monday? I can't remember. Anyone remember? When did we talk about use effect? Which lecture was that? Anyone know? Trying to recall. They've reshuffled things around. So in any event, we learned about the use effect hook. Oh, okay, right. Okay, that used to be a lecture that we used to hold all on use effect and data fetching, because it's quite a fascinating topic, how you get things to happen at certain times, okay? So we know that, what if I want something to happen when this component is first ready? Remember jQuery? We had a function called ready, or document.ready. And we know that use effect, that's all it is. All use effect is just document.ready. This code will run when the browser's ready. So any confusion about use effect is just document.ready with a couple of extra features, okay? So we'd go use effect, go use effect, which I can't do here, obviously. And we give it a function and stuff that would happen, and some empty curly braces. So that's we'd normally see in use effect, right? There. Obviously not going to work because this is this is not okay. Anyway, it looks like this. There, and there's our function there. And the empty braces mean run this code when the DOM is ready. Just like, yeah, just like that at all. Just like jQuery's document.ready. So if you have any questions about use effect, just think jQuery. It is the document.ready function. Okay. But of course, clearly I can't do this here because this is a class component. So how to make this work in a class component? Well, it turns out this is where we talk about what's called the life cycle of a class component. Okay. And for example, I want something to happen when the DOM is ready. When the document's ready, I want, maybe it's console log ready. I'll put a console log here, okay? So we have all these things called life cycle methods. And as part of the component, we inherit some of these. We already inherited a couple of things like set state. So we inherited set state from our React component. There's a bunch of other methods that we inherit from our parent or our superclass. And one of those is the life cycle methods. And one of them is called this. Component did mount. There. So this is one of those OOP concepts. It's called overriding. Okay, you can override a method that is present in your superclass. Remember our little rectangle here and our there, where we can also declare our own area here. And when we call this one, of course, now it will override the one it got from its parent. So we const like area, we're going to get probably undefined, it looks like. So you can override a method from your parent. Well, the same with our class component. Now, the default version of this looks like that. It is an empty function. It doesn't do anything. So it is perfectly safe to override. You don't have to call the super version of it, okay? So we just call this, I can say console log document ready to use jQuery terms. I miss jQuery. There, okay, let's take a look. Document ready, not so bad. So instead of a use effect with square brackets, we have to just call this or define component did mount. Not so bad. You only get one of them. You can't do multiples. Unlike with functional components, you can have as many use effects as you want with an empty brace. With a class component, you get one shot. That's all you get. You can't declare it again. If I do that, I'm going to probably get some nasty error. It's not going to like it. Okay. So you get one chance. And it works. Did document ready. Okay, which I spelled wrong. Document. So that's one of the things. What about if something changes? Remember we used use effect? We can have things to listen to in the dependency array of use effect. We can listen to maybe counter changing. If counter changes, then I can do something. I can react to that change of state and maybe do something else in my code. I'll use effect. So I'd put counter in my dependency. Well, with class components, it's a bit different. Once again, we use a life cycle method. This one is called component. Gives you some choices. Component did update. This means something changed. Something changed in my component. Right. Let's console log. Console log. I'll say something changed. Yeah, question mark. Did something change? Let's take a look. Oh, something changed. Okay. Looks like something changed as well. Yeah, so stuff is changing on me. Okay, awesome. Now I can respond to that. Well, the obvious question is what? No, it really is. What? What changed? What changed? I could have tons of state, maybe 30, 40 items in here. Which of these things changed? How do I know? Now with use effect, I can list them in my dependency array, and when something specific changes, I can do something else specific. For instance, if my counter changes, I want to do something specific. But if the text changes, I want to do something else very specific. But I just said something changed. Okay. Well, what can I do here? Okay. Well, it turns out you get two parameters with your component did update. You get the previous props and the previous state. Okay. Okay, well, that's useful. How does that help me? Well, it turns out we can then compare that to our existing state or props. So for instance, I can say, well, okay, I can go if my this dot state dot counter is not equal to my prev state dot counter, well, I'm going to say counter changed. There. I'll put my little console log here. Once again, let's put this here as well. I'll also put something changed. There. What changed? Okay, let's give it a try. So what changed? Oh, counter changed. Counter, counter, counter. There. Likewise, I could do the same thing with my text. This dot state dot text is not equal to my prev state dot text. Then I know that my text changed. Take a look. Counter changed, and text change. So you may ask yourself, well, this is kind of inefficient. Yeah, it is a little bit cumbersome. You have to, because you only got one of these. This fires only once. You can't have multiple use effects. You only get one chance. Then you have to have all these ifs. And people wrote all kinds of libraries and modules around analyzing, did the state change? You can imagine a whole ecosystem sprung up to support this fact that you just got one state and one prev state, and you have to do all these ifs, okay? And if you have a lot of stuff, this can be very, very cumbersome, as you can no doubt imagine, okay? It works, but it looks a little cumbersome, right? So there's our really equivalent of our use effect, okay? Not bad. What happens, how about cleanup? Remember we talked about when a component cleans up after itself. I think in use effect, we talked about that. When you make a change to the DOM, for instance, if I were to, in my did mount, if I had like an interval, const interval equals, and I put a set interval here, these are always scary. There. I'll give it a function, and I'll run it every second, like this. There we go. Okay. And the interval is simply console log. Console log interval fired. There. Okay. So now it fired. It's firing away. Look at that. Okay. But now, even if I destroy this component, the interval is going to exist. If I, in my app.js, maybe don't render that component, maybe I've got a conditional rendering, it will still be firing. Because what I've done, this is what's called a side effect. In other words, I've told the browser to do something that React doesn't keep track of. That's what a side effect is. When you read about effects, it's all this explanation, but really a side effect is telling the browser to do something that React isn't keeping track of, like an interval. It's just happening. There, React isn't doing this. That's just my 4850 now. Yeah. React doesn't know about it. It's just happening. It's permanent. It's essentially a change to the browser. And even if my component goes away, this interval still keeps ticking. Okay. So we have to do what's called a cleanup. Whenever you make a change to the DOM, like add a listener, add a timeout to the DOM itself, you have to undo that change when your component unrenders, or it's called unmounts. Now in use effect, it was easy. You simply return a function from the use effect. It was a piece of cake. But with class components, I have to have another lifecycle method, which was called component did or will unmount. It means the component is just about to be destroyed. And this is where we do cleanup. In this case, I need to clear this interval right there. Easy enough, we go clear interval like this, and then interval, but I don't have interval. Looks like I'm going to save this. And much like I would in anything in a functional component, I simply save it in state. So I'm going to say set state to an object with interval in it, and I know it will simply merge it into my existing state. Okay, and now I can clear state interval and take a look. Not defined. Better go this dot interval. I love it. Okay. Okay, so now when this component unmounts, I'll demonstrate that later, it will clear my interval. Okay, now I did something here that you should probably never do in a class component. You notice there's no interval here, is there? It doesn't exist. But I went and dynamically added another member to this state object dynamically. This is something you can do in class components. You just add stuff. So now if I go ahead and console log, I'll console log it in my button, my increment function. There, this is console log state. Console log this dot state, and you'll notice that my interval, or my state, now contains, try it again. Let's just clear it again. There we go. Contains interval. It changed. Let's do something a little better. Let's go ahead and instead we'll make our interval maybe 5 seconds. There. So now, right now, there you go. Hard to catch up on this thing. There. Okay. All right. So every 5 seconds it's firing. Okay. We try to avoid doing dynamic updates to our state. You can now. We really avoid doing that. Okay. Lots of fun. Okay. Who likes class components? They do have some advantages. Let's talk about the advantages of class components. This is now what's called a long-lived object. Unlike a functional component, the render, that's it. It's very short-lived. It gets destroyed on the next render, but a class component, it survives. As long as this thing is on the screen, this class component is still there. It's not being destroyed each time. This runs once, the constructor, and building all the functions, that happens once. After that, the only render is happening here. So this code is only running once. Now that's interesting because, as we know, with a functional component, all of our stuff runs, including building all the functions over again, building our new state, building all this stuff again. There is a cost for that. Okay, there's a performance cost for that. Now, we mitigate that using some other hooks and components, but out of the box, it's less efficient. So one could argue, yeah, class components are a bit more efficient. You don't have to worry about all this code running on every single render now, because that's the render, which is a lot smaller. So yeah, for that reason, it's not so bad. But the question is, at what cost? It seems like an awful lot to pay for simply gaining a bit of performance, and there are other ways to manage that in functional components. Let's quickly talk about React itself, okay, and where we came from with React. Let's go here. Okay. So when did React first come out? Okay, it was version 0.12.0. Okay. Actually, 0.3. Start with the very, very first one, 0.3.0. Okay. And the reason for that is they waited for ES6 to come out with classes, because otherwise you'd have to run a React dot create class function, which was awkward. Okay, so they waited for ES6. Okay, and then we have version 0.3. Okay, and then about a year and a half later, ES6 came out. Okay, and we had 0.12. Why? I have no idea. They just called it 0.12. And this contained ES6 classes. Okay, and this was November of 2014. So the first real usable version of React, November 21st, 2014. It's been it's almost 10 years now. Wow, okay, 9 years. And then they had version 0.13.0. And that was in March of 2015. Okay, so far so good. 0.14.0 in October 2015. Lots of interesting changes came out. Okay, whoops, 15. Okay. And then on April 7, 2016, we had version 15.0.0. Like, what happened there? Did they all of a sudden like jump ahead like 120 versions all the way to 15? First they were at 0. No, of course not. As you can see, all they did was simply call it 15. People had been referring to React 12 already, React 13. They were simply using that terminology anyways. React said, fine, we'll just call it version 15. They could have called it React 1.0.0. But who wants to use version 1.0 of anything, right? Like, I wouldn't buy a car in its first year of production, right? No, I'm going to wait a couple of years until it's proven that it's either good or bad. So the same with React. So they chose to go, their version 1.0 is actually version 15.0. And that was where things took off. Okay. The same thing happened. Anyone used Java before? We had Java, right? We had 1.2, 1.3, 1.4, 1.42. That's a very important one. 1.5. And then it kind of morphed into 5.0. It was kind of a transition period where people called it both. But after that, it was basically Java 6 with the occasional person calling it 1.6. It really varied. It's kind of funny. Okay. But now it's all Java 7, Java 8, like that as well. It happens all the time. Okay. It's one of those marketing things. All right. And then one that did come out, though, very important, was version 16.8.0. This release had a very specific name. Okay. It was called the one with hooks, exclamation mark. That was the name of the release. The one with hooks. The one before that, I forgot the release, was called, you can imagine, not the one with hooks. This was what it was called. People were waiting for hooks so impatiently. They knew it was coming because before this, React always had functional components. They were always there. We had a functional component which had a return. They were always there. It's not like functional components are the new kid on the block. They always existed. But one thing they couldn't do, they could not hold state. So what they were called, they had a term, they were called stateless components. And you'll still see this term referenced in a lot of documents. Stateless component basically means a functional component, which of course is no longer true. Now we know functional components can hold state. because the one with hooks. And this was 2019, and I believe it was February. This was a huge day in history. Everything changed. In fact, Lighthouse Labs changed their entire curriculum that year. And by summer, we were teaching functional components for React. Everyone changed. Everyone jumped on board functional components. Can anyone guess why? Well, yeah, why not? I mean, look at this. Look at this stuff. The reason is this is hard to debug. A class is very difficult to debug because this part runs once and this is run many, but a function just runs there. Really, so I can put a debug here. Yeah, console log count. I'll just console log count. What's count at this point in my component? Well, I can tell you, right? It's probably 0 when it first runs. Very easy to debug, but class components were quite difficult to debug, as you can imagine. And there was a big problem with this. In fact, we got so used to seeing this is not defined, we basically became numb to it, which is why it was before I was like, oh, not again. This is not defined. It happened all the time. Okay. So everyone jumped on board React functional components because of this. Okay. Huh, another joke. Look at that. They write themselves. It's fantastic. Okay. Let's take a look. Quickly, let's take a look. I've got a little diagram here. It explains how they work. Here's how a class component works. So the first thing is the component mounts. It calls its constructor, which is this part here. This gets called once. Okay. Then it does the render. So it calls this thing. And then the components or the component is established. Okay. It's now in the DOM. Once the browser has rendered it, it calls our component mount. It calls this. Okay. Then the class is surviving. It has a life cycle. We do an update, maybe a set state. Sure, we call some set state, triggers a render. So that hasn't changed, right? It's still React. It still reacts to changes in the state. Calls our render, and then React updates, calls this component to update with these crazy ifs in them you have to go searching for. Right there, okay? And then at the very end, it unmounts. It tells us the component is just about to unmount. Okay, so that's kind of the story of React class components. They are a bit tricky. You will see them though. You see them online. You will likely see them in a job, particularly if you have a company that you work for who's been doing React for a while, because React class components were around for years before functional components, and companies invested a lot of money in class components. Okay, so the question, which I know is on your mind, on everyone's mind, is when should we use class components? When should we use them? I have a diagram that describes that really well. Let me take a look here. There we go. Don't. Yes. This diagram really nicely explains when we should use class components. I like this diagram because in its simplicity, and anywhere you start on the circle, it all ends up at the same place. It's really great. It's a really great graphic as to when to use class components. You probably should not, okay? However, maybe if someone's going to give you a lot of money, someone pays you a lot of money to use them, I'll do it. Hey, my principles are for sale, right? I'll do it. Sure. Give me lots of money. I'll go ahead and write some class components. Okay. I'll feel a little dirty about myself and won't feel so good. But hey, I'll still sleep soundly because you pay me lots of money. Or more likely is converting old to FC, very common, or supporting older code. So you might see them, okay? But as far as new code, once again, follow the graphic. don't make new code with class components. All right, everyone, that is our talk today on class components. We do, I think, a little bit of work, not much in Compass. You might see them in the wild, and now we know that this is a real problem with class components. All right, everyone, have a great rest of your day.